Hello, my name is Tim Grandjean, and I've completed a report regarding the uprising technology of air source heat pumps and their popularity as part of my communications course in the Energy Systems Engineering program at Holland College. To start, I'd like to give you guys some background on this technology. So first, there are two different kinds of heat pumps: ground source, also known as geothermal, and air source heat pumps. Both types are very versatile for the homeowner as they provide both heating and cooling. The uprising of the technology is mostly due to the fact that the system is more economically feasible for the homeowner, and it's also very easy to install. Also, the systems are known to be much more efficient and low carbon emitting. So these systems come in two varieties. Most are air to air, meaning that they draw air from either indoor or outdoor, depending on the heating or cooling mode, in order to heat the air or cool the air in the house. So the other system is air to water system, which is pretty much identical except it's used to heat the hot water system in the house. The process is actually very simple. It's pretty much like a refrigeration systems cycle. So basically, you have two copper tubing coils that are both wrapped in foil for optimum heat transfer, a compressor, and refrigerant. The refrigerant constantly comes and goes through the outdoor coil, and then it gets transferred into the house, extracting the heat from both the outside air and the outer coil before it turns into the form of vapor. And then it proceeds to go through the inner coil as it switches back to its original form while releasing the heat to the air. In cooling mode, this would actually be the opposite. So instead of releasing the heat into the air, you would be doing the same thing except for extracting the heat out of the indoor air and bringing it outside. Cooling mode is actually enabled by a reversing valve, which basically just allows the refrigerant to flow in both directions. The main repercussion with one of these technologies is the fact that they're not designed to run at super low temperatures, so it does kind of cause a little bit of an issue in our climate. Luckily, if the system gets frozen, all systems have a defrost mode. There are two types of defrost modes. So there's demand defrost, which will automatically sense that there is something going on, either it's too cold or the coil has frozen. Or there's time temperature defrost, which means that the user will set up the time intervals at which it should be defrosted. In defrost mode, basically all that happens is the system sends refrigerant out to the coil to defrost it at a higher temperature. Although the defrost mode does come in handy, it's important to avoid it because it can reduce system efficiency by up to 10%. Basically, how you would avoid it is switching to your oil or your other backup system in order to save your heat pump. So, design considerations. The first thing, is to air seal before you want to switch your system. This will reduce the overall load demand of your house, which will save you money in two ways. One, you're not going to need as big of a system, lower capacity, of course. And two, it will reduce your monthly utility bills, so you're not going to be paying as much for your electricity or your heating. Another big thing that people might forget about is the location of the thermostat. So you want to keep it away from hot and cold sources, like radiators, windows that get direct sunlight during the day, drafty areas, and building envelope penetrations that get opened a lot during the winter, like your main door. Potentially, if you ever open your windows in the winter, that should also be avoided as well. Another big thing that people don't think about is that the system's not going to work any faster if you turn it up to 20 when you're just looking to get 17 degrees. It's actually only going to waste energy, and it's not going to work any faster. As for advantages and disadvantages, the advantages definitely outweigh the disadvantages. But the big thing is that these systems are known to save you money because of a thing called the COP, which is the coefficient of performance. Generally, they range around 3, which means that you're paying for 1 unit of energy and you're getting 3 out. So it's like 300% efficiency, whereas most oil boilers will run at around, if you're lucky, 80% efficiency. These systems are also ideal for in-floor heating because they produce water at around 45 degrees Celsius on average, which is the exact temperature that you want for that stuff. This can also be a disadvantage because producing the water at a lower temperature for a high temperature in the house can lead to the system having to work harder. although this can be avoided with proper air sealing and proper sizing of the system. As I already mentioned, they're low carbon emitting, but they also have potential to be zero carbon emitting because they run on electricity. With the world's way of moving these days, implementing renewable energy resources could allow us to actually have them run on zero carbon emission. They also provide us with heating and cooling modes, so it'll save you from getting an air conditioner. They're known to be less maintenance, which can save time and money, of course. Time is money. They're also easier to install than ground source heat pumps and also your typical heating system, and they're more versatile, so you can put them pretty much anywhere. You can put them in a flat, you can put them in a townhouse, you can put them literally anywhere. They can be sized as low as 8,000 BTUs per hour. So the main disadvantages are that you will get problems and failure of your components if you fail to defrost, or if your system fails to defrost. This will lead to more maintenance, but it can also be avoided. They also make a bit of noise because of the fan that's in them. As I already mentioned, they produce water at lower temperature, and for colder climate applications like us, there is less heat to be harvested, but at the end of the day, these disadvantages really don't make that much of a difference. As for the effect on the utility provider, my class was actually able to tour the Maritime Electric power generation plant here in Charlottetown, and I had the opportunity at the end of the tour to ask the chief of operations a couple questions regarding the effect that the rise in air source heat pumps has put on them. So first thing he said was that really it came out of nowhere for them. The grant caused the installation of these systems to spike incredibly, which ended up increasing the load demand incredibly, which forced them into spending an incredible amount of money, a multi-million-dollar project on a very inefficient gas turbine, so that they could support peak load demands during the cold months of the winter. Now they're in the works of another multi-million-dollar project, which is the installation of 2 extra 100 megawatt cables on top of the other 2 100 megawatt cables that they have now. And this will allow them to be ready for any other kind of event like this. In conclusion, as I mentioned earlier, air source heat pumps are becoming increasingly popular simply because they can save people money, and anyone these days is going to save money anywhere that they can. The technology basically extracts heat from cold air during heating season and removes heat from indoor air during cooling season. The number one thing to look at before you're installing one of these systems is air sealing. It reduces the load and it will provide you with a cheaper system. Now, as I displayed earlier, the advantages of installing one of these definitely outweigh the disadvantages. And although it might put a strain on the utility, they're here to serve the people and they're not there for themselves. And here's a slide that displays the references I used to perform my report. I did a lot of good research before I decided to write this. I hope that the screencast was informative to you and has opened your eyes up and will help you if you are planning on installing one of these systems in the future. Thank you for your time.